All right, everyone, we are just about getting ready to start. Welcome all back to our last session for Monday. This one is going to be called Transistor, a bitemporal database client by Julia Naomi and Otavio Paulino. We have Otavio here, and as soon as we get Julia as well, we can go ahead and do the introductions. Actually, I'll start with that. Let's go ahead and do the introductions, and then we'll do the video here. Okay, so let's go ahead and start with the bio. Julia Naomi is currently a senior software engineer at Nubank using Clojure and Datomic while trying to migrate most critical services to Rust. She worked 3 years at ThoughtWorks with projects in both Clojure and Rust, and before that, she was a game developer. And instead, Otávio Paulino Pace is a senior developer at Louisa Labs. He describes himself as a passionate developer who works mostly with back-end web development. So in this video, we'll learn how Naomi and Otávio developed a Rust client for a bitemporal database based on Clojure that uses Datalog as its query language. So we'll go ahead and start the video. Please stay tuned. Of course, we'll do a live Q&A at the end. And for those of you who haven't seen the other talks today, we'd like to keep the questions separate. So if you look at the chat box, we have one bubble that says room chat and then another circle that says Q&A. Please direct your questions for our speakers to that chat box. Thank you very much. All right, we'll start the video and enjoy. Thanks.
Hello all. We are going to talk about Transistor, a bitemporal database client. My name is Julia Naomi. I'm a Rust evangelist at Nubank, but I mostly program in Clojure. I'm a hobbyist game developer trying to convert the C++ world into Rust. My GitHub account is Naomi, and my Twitter account is GrowGameDev.
Hi, I am Otávio Pace. I'm a bug developer at Louisa Labs, Rust testing on spare time, and that's my GitHub account.
So our agenda today is talk about Crux. What's Crux? The bitemporal database that we will talk about. What is Transistor? Our client for this database. What is Eden? Why we need an Eden ecosystem, and our libs Eden and Eden RS. Eden is basically the format for Crux.
So what is Crux? Crux is a database, and the main features are these ones. So it's bitemporal. We'll get on this later. It is schemaless. So there's no concept such as tables, and you don't have to enforce a schema to insert data or retrieve data. It uses Datalog for the queries, and like SQL is more of a recent thing. But the native one is Datalog. Like both are native, but SQL is probably something to bring more people to actually use this database. And it is unbundled and decoupled. So you can actually have multiple backends, like you can store some parts of the data on Kafka. Well, not like some tables in a part or some tables in another backend, but more like the indexes go here and the data goes here, and you have multiple backends. It's very decoupled. So temporality. What is temporality? Imagine you have you have on the database some product, which here is cool shoes, and you have 42 of it. So you insert it on the database, And every time you insert something on Crux, you will have a transaction time on that document. And when you try to update it by using the same ID, you, like here we're updating the quantity, we actually will create a new registry on the database, and it will have another transaction time. So on Crux, you have all versions of the documents across time. So here, for example, let's say you find for the ID1. Let's say the ID1 has 2 versions of that document. If you only are finding, like the default find is just to get the latest version. But you can, as shown on the ID2, you can find all of the versions. You can just get some of them. You can do all kinds of things like that. And the bitemporality thing is because on Crux, not only there's the transaction time, but there's also the valid time. Transaction time is defined by the time that you've inserted the document, that version of the document. And valid time, you can actually use, you can set it yourself. And the bitemporality thing is the feature is basically that you can use those 2 dates to go across time on the database to find and do all sorts of cool things with it. And the main operations that Crux supports are put, delete, match, and evict. So put is just putting, like inserting a new version of a document. And deleting, it basically gets a document at a given valid time and removes it. It won't actually like delete the document itself. The evict is operation is used for that, which actually removes the document entirely out of the database. And the match operation, you can have a document on memory, check it to see if it is the same as the database, and if it is, you can keep doing other operations. So it's a very cool feature for like stopping a transaction, which is just a set of operations like if the database isn't how you think it is. And this is actually how we do it on our library, Transistor, which Julie is going to talk about now.
So what is Transistor? Transistor is our Rust client solution to query and make transactions to Crux. So when we took the shot of this of the Crux.io, it was in the version 1.32. Now it's around version 1.310. It's a very complete crate. It has many docs, a few examples, and all the roadmap is in GitHub. The basic feature, the basic functionality to start using Transistor is the HTTP client that can be found in the module client, the struct Crux. To create this struct, you need to send a host and a port, like Crux new, host and port. And to retrieve the client, you just use HTTP client function, and it will retrieve it for you. If you need this client to have an authorization code, you can just use the function with authorization and send a myauth token. So how to insert and update something in the database? First, we can just create a struct. Transistor requires for the put operation, delete operation, match operation to have a CruxDB ID that has a very specific syntax. It's crux underscore underscore db underscore 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 ID, and it's of type crux ID. This will automatically convert the string, the struct into a string, that put operation can be interpreted. So we send put, we send the serialized string, and then we can send an option value down. So if you do this many times, you will be able to update the document. If you do it like one time or just the first time, you will be just inserting the first time. The txlog function receives a vector of actions, so you can send many puts, matches, deletes, and evicts all together in a vector. And next, and to query, it uses a edn flavor datalog that Otávio talked about before. So the basic query starts with the query flag, and then you have a find, which are the elements that you want to find. The where are the clauses. So you want to find a P entity that has name Julia. And if you use the flag full results, it will bring the whole document. If you don't use it, it will just bring the name in this case. If you use like age or something other in the where, it will bring other features as well. So if you want to understand the comparison between these and select, find is similar to the select. From, it just says like the table or somewhere is not really important for Crux. Where is mostly the same, so you have where name equals Julia, and the full results is the asterisk in select. If you don't use it, it will just retrieve like select name from persons where name equals Julia. So how to query in Transistor? We have a struct called query that it has two required fields, find and where. So whenever you start to query, you need to find something that's a vector of elements that you want to find, and a where clause that's all the clauses that you want to match this find to find the result. So if you want to find a P with name Julia, you just use this. If you want to find a P and an A, like I have a P with name Julia, and in this P I want to find an age A. So then you can retrieve the A from the vec. And with full results, it just means that you want all the results. And if you use build, it would generate the query, the serialized query. And then you send to query with function query, and it's done. So entity is similar to a find by ID. It's one of the most important functions in Transistor. When you send to entity, you send the Crux ID that you have, and it will retrieve the latest document for this ID in an edn format. And here it starts to become important to understand why we have an edn ecosystem, because we need to support Crux edn syntax. Okay. So also, we developed an async await feature for Crux, because in the beginning we started using request blocking client, and then we understood that we needed to provide an async client. So first we started implementing async support for edn-rs, and when we learned enough about async with edn, we started to developing async support for Transistor with request. So now the crate has this async feature. You can just click it like you want to sync, and then you will use the client the same way You just need to use await at the end.
Okay, so what is EDN? EDN stands for a extensible data notation, and it is a subset of the Clojure programming language. And like you can map, just as we saw like that product, to some parts of it you can map easily to similar JSON. So there we were showing kind of like an object with 3 properties, and we will show more later. But the spec is actually very little, very, very small, and you can find it on this GitHub repository. So here are some examples. So there's how you do new values here. And then you have booleans, strings, characters, symbols, keywords, which are similar to Elixir atoms or Ruby symbols, I think. Numbers, you have maps, which are keys and values. And there are lists. There are 3 types of lists, actually. So this one is a list which you can't access an element like randomly, an element by the index, and here you can. Usually this is implemented as a linked list. It depends on the implementation, and this is a set. So you only you don't have duplicate values. So all of them are unique. And I think this is you. No. Oh, sorry. Okay. So why do we need an EDN ecosystem? So the libraries that we've made are Transistor, edn-rs, and edn-derive. Transistor is the one that Julia has just shown how to use it. And to actually make Transistor possible, we needed to do those 2 to make it easier and make it possible and easier to handle EDN format in Rust.
So the base of everything started with edn-rs. It's our EDN library. We looked for something that did what we wanted for EDN. There was some solutions. None of them did what we wanted. So we started to implement our own solution. This is, it's currently in the version 0.16. We are saying it's near stable because we have a macro that still has a bug, and we haven't found a way to solve that bug. So that's why it's still near stable, but it's not going to have any breaking change so soon. So our basic EDN has all those formats that Otávio said, and a few more. So instant and UUID and namespace maps, they are part of the Clojure of the EDN spec. So we implemented them, and their representation is in green at the right. So yeah, those are all the types that we have. And this is actually the macro that we have a problem with sets. So this macro, it uses, it can receive an EDN format and parse it to an EDN Rust type. So in the example here, we have a list containing a symbol, a double, integer, a boolean, a keyword, new, and a rational. There's an interesting thing about Clojure. Rational types, they are not resolved to float or doubles. So only if you use double for that. And then the macro parses this format into an EDN type. Next. So when you create a macro, when you create an edn, it's also possible to navigate through it. So you can navigate, like if you go to the index, you can navigate with keywords, and there's another possibility that's not represented here, but like in the edn double, you could just use toFloat and you will receive the F64 representation of it. The same goes for strings, booleans, integers, rationals. You can have like a Rust representation at the end. You just use toString, to boolean, to integer, to float, and that will be enough. Next. So everything starts with the parsing function that we called from str, which receives an edn string, and then it parses it to a edn Rust type, just as the example is showing us. The map representation, it uses a string containing the keyword or whatever is the key, and then it has the edn type, that's the value, whatever it is. Next. So we also have an emit function. So if you have an edn format, you can emit it to string. So we can use edn to string as well as edn rs dot to string with the edn, and you receive the string that the Rust type edn contains. You can also use a debug mode to receive the edn type representation in debug. That's called toDebug. So there's another feature that we can directly convert an edn to a struct. This can be done with the function from edn. So we create an edn representation, and then we use from edn directly to a struct. Most types are already serializable, so their representation will be done automatically. And so we can have edn to string and edn to debug. These are the difference between them. So the toString is a pure edn format, and the toDebug uses the Rust representation of this edn. Next. Now, Otávio.
Okay, so let's talk about edn-derive. So Julia shown like the edn-rs library, which is the core of how we actually create the edn strings and convert them to Rust types. But this library actually, we built it to make it easier so that we can just with one line like do the conversion pretty easily for any Rust type. So again, just as Julia said on the other examples, this is on another version. I don't remember the number now, but it is farther than this. And so how do you serialize it? Like that being converting a struct to a string, a valid a edn string actually. So here you just have to put this derive serialize, and of course you have to do the use statement, but just by putting this, you can actually use the toString from edn-rs, and you have the string converted to you normally. So just for edn-derive is very handy to make it very easy to use edn-rs on Rust types. And this is for deserialize. You don't actually need the debug and partial equal. We just put it here because we are using assert equal, and that's a requirement for printing and comparing the types. But you don't need them if you won't compare them. And the deserialize will make you will make your struct able to convert the string to it, to like deserialize the string to that type. And you just use the from str function that Julia shown earlier. And there's a clear Serde inspiration. So on the left, you can see a Serde example, which is I think the most popular serialization library on the Rust community. And you can see that they have those two main functions, the toString and the from str. We just follow the same pattern to make it easier to use and to be more familiar. And you can actually like use both on the same project. Julie actually has a project on this for a new format that's happening on the financial system here in Brazil. And so here you can see that you just have to do renaming. Like you can just rename one of them, but we've renamed both of them here so that it's clear which is which, but you can put whatever name you want. And the names won't conflict. It works perfectly. And Julia shown earlier the thing about the Crux ID being like with lots of underscores. That has a reason. That's because on EDN, actually, we're converting that, like when we find on a Rust field two underscores, we convert it to a dot, and 3, we convert it to a slash, which are both very common characters on, like, especially the slash is very common on EDN and Clojure. So the way we've done to actually serialize and deserialize it is to use this underscore notation or conversion. And on regular underscores, on like operation type, we convert to dashes. And on enums, we actually create a namespace. So we could just do column deposit. That's a valid keyword for like this, for example. But to actually separate different enums, we've created this namespace to give it more more identification on which is which and what is what. So yeah. And here are some references. So here's the ATM Crux, which is basically a ATM that a GUI application that Juliet made using both edn-rs and Crux. BR code, which is that library that Julia used both Serde and edn libraries. And this is Smog. Smog is an API using Actix Web and Transistor. And just as ATM Crux is a program for dealing with accounts and doing transactions, this is the same, but an API. For people who want to learn more about doing procedural macros, like edn-derive, we recommend looking at this repository, which is how I've learned, actually. We used as a reference, and the edn-derive is actually pretty simple. You can read it. It's not like you can read through the commits. Is not that complicated. If you have any doubt, you can contact us or create an issue to understand it. We can explain it. And here's the Crux database webpage, so you can read the documentation if you want. So, thank you.
Thank you.
Fantastic. All right. Well, you guys, that was actually the last video that we had for today. So if you have any questions at all that you would like to ask our speakers, please direct them to the Q&A. We're actually live, ready to go live with Otávio. He is here to answer any questions. I see one first of all. So Otávio, let me turn on your camera. Here we are. Welcome back. Hi. Great to have you back here.
Hi.
Thanks again for your contribution to RustLab. I wanted to ask, did you have anything you wanted to add from the video?
I just realized we didn't put the links to our repository. Like we had some references at the end, but not the three repositories. I will put them on the chat.
Wonderful. Thank you for that. Awesome. All right. So in the meantime, let's proceed with the questions. I have one question here from Michele D'Amico, who says, Transistor's async support is done over request. Does that mean that we always need Tokyo to use it? We cannot use it with async STD, right?
Yes. Unfortunately, like I didn't know about that, and there's this issue on request that basically talks about this matter that they only support Tokyo for now. I don't know if they will support any other kind of sync runtime, but maybe we can do something on Transistor to support other types of runtimes, but for now it's just Tokyo.
Okay, great. Thank you for that. Anyone else have questions for Otavio here? Thank you for those links. I'm sure people will want to check them out. All right. Well, if that is it, then I want to say, Otavio, thank you for coming again. Hopefully, the next edition of RustLab will be in person, so we can see you there, hopefully. Wonderful.
Thanks for receiving us. Unfortunately, Julia didn't appear. I think she wasn't feeling very well yesterday, but she's probably fine. Just I don't know, like, but thanks for having us. Like, I don't know.
Yeah, we'll hope to see you again next time, next edition. So have a great rest of your day. Thanks.
Thanks. You too.
Thank you. All right, everyone. Well, that actually marks the end of day one for RustLab 2020. Tomorrow, we have a 3-hour workshop by Mario Garcia starting at 12:30 p.m., which is about create and deploy your first Rust web app. So we hope to see you there. Let's see if we have any other communications. I think that is all for today. Yes. All right, everyone. Hope you have a great rest of your day, and I'll see you here tomorrow for day 2 of RustLab. Take care. Goodbye.